Hi everyone and welcome back to Matthew Wister. Today we're going to be talking about the pH scale, acids and bases in chemistry. So to start off, the pH scale or the pH is a measurement of the amount of H3O plus or H plus ions and OH minus ions. Now H3O plus ions stands for hydronium ions and OH minus ions stands for hydroxide ions. Now the pH scale follows a logarithmic scale, where each value is 10 times greater than the next higher value. For instance, let's say I have a pH of 6 and I go to a pH of 5. The pH is changing by a factor of 10. Now let's say if I go from 6 to a 3, now I'm changing from 10 to 100 to 1,000. So the factor is changing by 1,000. Now it's going to get more specific when we start to talk about the hydronium versus hydroxide ions. So here in our scale, we see that we have acid, neutral, and basic. Now neutral is always going to be with a pH of 7, so it's going to be right in the middle. And an example of something with a pH of 7 is pure distilled water. Now on the left side, we have our acids. So our acids are typically those with a pH that's less than 7. So from 6 to 0. As we go more down, more to the left, we're becoming more acidic. And what that means is that our concentration, which is shown by the brackets here, the concentration of hydronium ions is going to increase as it becomes more acidic. However, the concentration of hydroxide ions is going to decrease as we become more acidic. However, now if we look at the right, with those that have a pH higher than 7, which is heading towards a basic, these are our bases. So as we become more basic, the concentration of hydroxide ions is going to increase while the concentration of the hydronium ions is going to decrease. So let's take an example here. Let's say our initial pH is 4. So let me mark that down. Our pH starts here. That's our starting point with a pH of 4. Now it says the concentration of hydronium ions is increasing by a factor of 100, and specifically hydronium ions. So we already know that the concentration of hydronium ions increases as we become more acidic. So we already know that we need to be looking around here in this area here. Now if it's becoming more acidic, we know that we're going to go more to the left, closer to 0. Now more specifically, it says that it's increasing by a factor of 100. If we remember, the pH scale, again, is moving in a logarithmic scale. So each value goes either increases or decreases in a tenfold scale. So one simple jump, right, is only 10, right, to the power of 1, because it's logarithmic. But now, if we do 10 to the power of 2, that's going to equal 100. So that means we're going to do 2 jumps to the left because it's becoming more acidic. So we're going from 1 to 2. This goes from 10 to the power of 1, 10 to the power of 2, which is 100. And it leads us to a pH of 2. Therefore, our new pH is 2. Now again, we were able to identify this because we know that the concentration of hydronium ions, which is here, increases as it becomes more acidic. So we know that it has to be going this way. Now, another thing that I want to talk about when it comes to acids and bases is how to identify them. So now more specifically, let's talk about arrhenius acids and arrhenius bases. So arrhenius acids are substances that dissolve in water to form H plus ions, or hydronium. Now, these acids, they're electrolytes because they produce ions when they dissolve. Now, as we talked about earlier, the possible pH values for acidic solutions are those below the pH of 7. Now, a way to detect an acid is that they typically start with the letter H. And an example is HNO3. Now let's talk about arrhenius bases. Well, arrhenius bases are those that produce OH minus or hydroxide ions when dissolved in water. So similarly to arrhenius acids, arrhenius bases are also electrolytes because they produce ions when dissolved. And again, as we talked about earlier, the possible pH values for arrhenius bases are those above 7. And last but not least, these bases typically end with the letter OH. KOH. Now, the last thing I want to talk about is neutralization. Neutralization is the process where an arrhenius acid and arrhenius base react to form salt and water. And an example of this is, as we can see here, we have our acid, HNO3, because we see that it starts with the letter H. We have our base, KOH, because it ends up with the letters OH. And then we have our salt, and then we have our water, H2O. Now, when we're looking at the pH scale, right, sometimes we have indicators that tell us the appropriate pH range for a color change. Now, sometimes, whenever there is a pH change, we're going to be able to see this through a change in color. And typically, you're going to receive a table that's going to tell you the indicator, the color change, and the appropriate pH range for the color change.